Hey guys, this is Nitin from FTC Team 18172, Uplift Robotics, and in this video, I'll be explaining some of the functionality within Mechanism Mode. Mechanism Mode takes the kinematic constraints that you create within your Creo model and establish relationships between those constraints in order to simulate the motion of multiple components similar to how they'd physically act. Mechanism Mode can not only be used to simulate those components, but also create animations based on the motion of your Creo model. In the first video in our advanced CAD series, we showed the power of Mechanism Mode by simulating projectile motion within Creo. So in this video, I'll be breaking down some of the different features within Mechanism Mode, but I'll touch on the most useful ones for our use cases in FTC. If you want to learn more about the advanced capabilities within Mechanism Mode, then you can always contact our team in the comment section or through our social media. Alright, since the previous video on sketch tools within Creo, I've gone ahead and assembled the motors and the wheels. I also use kinematic constraints for the axles and pulleys. So now if I go ahead and use the drag components command and click on the pulley that I want to rotate, you can see that the pulley moves, and then I can also independently move the wheel and the pulley there as well. But you'll notice that these two don't move together like they would if they had a belt connecting each other. So in order to simulate this type of motion, we need to go into Mechanism Mode. So I'm going to go into Mechanism Mode through the Applications tab, and then click on the gears right here that say Mechanism. And now we're in Mechanism Mode. So here there's a lot of different features in order to simulate different types of components within Creo, but I'll stick to the most useful ones that we have in FTC. So for my model, I want to create a belt connection. So I'm going to go over to the Connections group and click on the Belts command. And within here, I can go to the References tab. And now you'll notice that I need to select two items for the references of my pulleys. So for the first pulley, I have a pitch diameter sketch line, and I'll select that. And then using the Control key, I'll select the pitch diameter of the second pulley. So I have a sketch line for that as well. So I'll select on that right there. And now you notice that it automatically figures out the belt with this green line. So right now my belt is already satisfied, so I can just go ahead and click the green check mark. So now if I go back to the drag components command, I can go back and drag this first pulley right here, and now you notice that it automatically moves the wheel for me. In addition to connections, you can also use motors to power your mechanisms and perform analyses based on your motors. So in this case, I want my motors to spin the wheel. In order to create a motor, I can go to the Servo Motors command right here and click on it. And under the References tab, I can select the motion axis of the pin constraint on this first pulley. So I'll select on this motion axis, and I can go to the Profile Details tab. And under the Profile Details, I can change the driven quantity to be either position, velocity, acceleration, or torque. In this case, for our motor, I want an angular velocity. And I'll leave the function type as constant, but you can always mess around with this as well. For the coefficient, you'll notice that Creo actually requires the degrees in seconds. I know the RPM of my motor, so I'm just simply going to just input the RPM and then convert it over to degrees in seconds. And now I have my motor fully defined, so I can click the check mark. Now I can set up an analysis in order to generate the motion of my wheel. So I can go over to the Mechanism Analysis command, and it opens up in a new dialog box. You can change the name of your mechanism analysis, but the first thing I'm going to do is change the type. For the type, there's a few different options, but I'm going to select the Kinematic Type, and this is useful for certain kinds of connections such as gears and belts, and using the motors in order to drive them. You can also use dynamic analyses in order to generate animations for the more complex types of connections, such as CAM and 3D contacts, but I'll stick with the kinematic type for now. If I go over to the Motors tab, you notice that the motor that I just defined is included in here, and you can always exclude or include certain motors depending on what your goal is. I can go over to the Preferences tab and change the duration and the frame rate of my analysis. So I'm going to change the end time to be 2 seconds, and you can always increase the frame rate if you're trying to generate an animation, but for this purpose, I'm not going to. So now my analysis is fully defined, so I can hit run. And now you notice that my wheel is automatically being spun. I can click OK. And now there's been a playback feature generated. So if I scroll down in the mechanism tree, I can go to the playback feature and hit play on it. Now you notice it opens up this animate dialog box, and I can use the different commands in here to play back that same animation. If you want to create an animation, you can just hit the capture button, and you can render and export it in different formats, but I won't do that for now. I'll hit cancel and close out of that. Alright, so in this assembly, I'm going to use the gear connection to connect these two gears. Right now, if I use drag components, and if I drag one of the gears, you'll notice that the other gear isn't actually moving in reference to the larger gear. So I can close out of this, and I'm going to use a gear connection by going to the connections group and click on the gears command. It opens up in a new dialog box. So for the gear name, you can change that, but I'm going to change the type. So these two are spur gears, but you can also use bevel, worm, or rack and pinion gears. So I'll select on spur. The first thing it wants me to do is select the motion axis. So I'll select on the motion axis of the large gear. It automatically defines the body. So for the pitch circle, I can input the pitch diameter of this gear. So I know that this gear has a pitch number of teeth of 100, and then the DP is 31.75. So I can click enter, and it automatically figures it out for me. I can hit apply, and now I can go over to the second gear. So for this one, I need to define a second motion axis for the small gear, and I'll use that pin constraint. Now you notice that it automatically figured out all of the body and the pitch diameter automatically. So if I go and hit apply, and then to the properties tab, you notice that I can define the gear ratio in case if Creo got it wrong for some reason. You can use user defined. You can also change the pressure angle or the helix angle depending on if you're using a helical type gear. So I can hit OK since this is good. And now if I go back to the drag components and click drag on the large gear, you can notice that the smaller gear is now also moving in reference to this large gear. As usual, the Creo files made in this video will be in our GitHub repository in the description. If you have any questions about mechanism mode, Creo, or FTC in general, feel free to contact our team through our social media information in the description. As always, thanks for watching, and stay tuned for more tutorials in CAD, FTC, and more coming soon.